technologies that have been brought into the manufacturing sector. That all we are going to learn. Under that, we have three units. Unit 9, which is about technological innovations in manufacturing. And Unit 10 is modern manufacturing methods. And Unit 11 is automation and robotics. So here we will learn about technological innovations in manufacturing, modern manufacturing methods, as well as automation and robotics. So first we'll move to the technological innovations in the manufacturing. Whenever we say technological innovations in manufacturing, we'll just talk about the industry 4.0 and internet one thing, that is IoT, intelligent robotics, sustainable manufacturing, energy efficiency, and also what are the different sustainable things that is means the mostly the uh, industrial revolution or industry 4.0, it always talks about sustainable manufacturing, eco innovation. It talks about industry 4.0. So let's look into that. What actually the technology that has been taken place? What are the technological innovations that are brought into the in manufacturing sector? We'll try to understand and evaluate what are the innovations that are being introduced in the manufacturing sector. Industrial revolution was like almost the first revolution was in between 1760s and 1830s, where there were major innovations like starting from the we take steam engines, water wheel technologies, and many others, which have led to the automation of production line cycle. Later, the Frederick W. Taylor, who's the scientific management and talks about the different innovation that have been taking place, and sustainable manufacturing process, where we talk about IoT and 3D printing. And there they talked about earlier there was only means they always like to have a zero wastage, and the number of units or the hours that are being used, and the energy efficiency, pollution and waste management, sustainable manufacturing, and eco innovation. When you call this, we have an example like European Union's Environmental Technology Action Plan, which always aims to accelerate the development of environmental technologies and eco industries. Whereas that was about European countries, and when you talk about the Japanese government, it promotes the concept of eco innovation, a new field of techno social innovation which focuses on the environment and the people, and also OECD, which defines innovation as the implementation of new or significantly improved product or goods or services, or process or new marketing methods, a new organizational method in business practices, workplace organizations, or external relations. And when we talk about the innovation, you can just look at here what are the more radical and systematic improvement that are being introduced in corporate environmental practices. So that's just you can see the scope of Japan's eco innovation concept. And when we are talking about this, here we have technology, that the field is technology, business model, and social system, where its target is industry, social infrastructure, and personal lifestyle. When we talk about industry, we have manufacturing industry as well as service industry. And social infrastructure, when you talk infrastructure, consists of energy as well as transportation or urbanization and personal lifestyle. And if you just look at here, under manufacturing, when we're talking manufacturing industry, we have sustainable manufacturing technology we are using. We are innovative in R&D, that is research development, like energy saving or green energy. And when you talk about service, innovative research and development, building energy management systems. And business model, there we use green services, servicing or energy services. And societal system, we talk environmental labeling system or green investment we call. And in European Union, the eco innovation is considered to be support the wider objectives of its Lisbon strategy, that is for environmental technology action plan. And eco innovation, its meaning and dimension. Mostly, eco innovation refers to any new innovation or technology that significantly contributes to the sustainable development. And this could include innovations that reduce the impact of production on the environment and which in turn enhances resilience or that use natural resources in a more efficient way. And eco innovation recognizes the positive contribution that industry can have on both sustainable development and the competitive economy. The approach is always towards achieving sustainable production, which has changed in recent years with a shift in focus from end product solutions to an increased emphasis. And factors of eco innovation, when we talk, we have targets, mechanisms, and impacts. If you just look at here in this pictorial representation, where it is having three main facets of eco innovation, and in which eco innovation targets are like institutions, organizations, and marketing methods, where primarily non-technological change it will have and higher potential environmental benefits but more difficult to coordinate. Whereas other processes and products, it will have primarily technological change, which will means if you look at like an x-axis and y-axis, on x-axis we'll have modification, redesign, alternatives, and creation. That is eco innovation mechanisms. And y-axis we can take it as eco innovation targets. So if you just look at here on x-axis, we have modification, redesign, alternatives, and creation. Whereas on y-axis, we have process, products, institutions, organization, and marketing methods. Now look at here, we have manufacturing, sustainable manufacturing calls for multi-level eco innovations. So what's happening, how sustainable manufacturers are calling for multi-level eco innovations? You can just look at it. There is a conceptual relations between sustainable manufacturing and eco innovation. And you can just look at, have a glance on this. Again, if you take it to the next axis, modification, redesign, alternates, and creation. And on y-axis, if you take And on y-axis, if you're taking institutions, organizations, and marketing methods and products, process and products. So here, what is the first modification? They always try to have pollution control, cleaner production, eco efficiency, life cycle thinking, choose loop production. Then comes the industrial ecology. And just to look at here, this all comes under this down below before that green color pattern, what the white color showing, it's all about technological. After that, industrial ecology, that's about technological, it comes under. So, what's the present focus on current eco innovations? So, the present focus is on automotive and transport industry, iron and steel industry, electronics industry. And eco innovation examples for automotive and transport industry. So, if you take BMW group, the organization. They are improving energy efficiency of automobiles, and Toyota, if you take sustainable plants, and Michelin, if you take energy saving tires, and others, they have self service bicycle sharing system. And when you're talking about iron and steel industry, Siemens and VI have alternative iron making processes, and ULSAB and AVC have advanced high strength steel for automobiles. And when we're talking about the electronics industry, the IBM, it's Eco Innovation. It talks about energy efficiency in data centers, and electric Yokogawa Electric. They are energy saving controller for air conditioners, water pumps, and Sharp enhancing recycling of electronic appliances. And Xerox Industry has managed print services. So this is the mapping the primary focus of examples of eco innovation. Whatever we have discussed about, that's they are showing here in the representation of a chart or a graph. And when you talk about Industry 4.0, 4.0 is nothing new. It's nothing about the digital transformation of manufacturing in the fourth industrial revolution. So in the Industrial Revolution 4.0, the concentration is only on mainly focused on the digital transformation. And that to digital transformation of what? Digital transformation of manufacturing process or digital transformation of manufacturing concerns. So if you just look at here, this is the third platform which talks about innovation accelerators, OT, and manufacturing meet in transformation. So here we need IoT. When we talk about Industry 4.0, Industry 4.0 means these are the points that comes into picture. They are augmented reality, cybersecurity, Internet of Things, cloud computing, system integration, simulation, additive manufacturing, autonomous robots, and big data. This all comes under the 4.0 Industry 4.0. If you just look at here, when we're talking about Industry 4.0, the stage one, which talks about mechanization of steam engines or water, steam powers, this all comes under the first one. And in second, it was like technological electrification. And third was about computer or internet digital marketing, robotics, IT, and OT digitalization. When you come up with the four, it's convergence of IT and OT, autonomous machine or advanced mobile robotics, big data. This all comes under the four. So this is how the transformation of 4.0 to fourth industrial resolution revolution. And this is from automation period to industrial transformation with industry. Integration of industry. So here we have when you talk about integration of industry 4.0, we have vertical integration as well as horizontal integration. And the components of industry, we have system integration, big data and analytics, simulation and virtualization, Internet of Things, the cloud, cybersecurity, automation robotics, augmented reality, and additive manufacturing. There are many application examples already that exist for nine technologies. If you just take here, advanced robotics, it talks about autonomous or cooperating industrial robotics, robots, and additive manufacturing, that is 3D printing, 3D facilities, and augmented realities for maintenance or logistics, and simulation is for simulation of value networks. When you talk about horizontal or vertical integration, it's cross company data integration, and industrial internet is talk about network of machines and products. And the cloud, it's of huge data volume. And cyber security, it's operation of networks and open systems. And big data analytics talks about like full evaluation of available data like ERP, CRM. Now, benefits of Industry 4.0: increased efficiency in production, more potential for innovation, accelerated response to customer needs, reduced cost and higher profit margins, quality assurance, and fluid collaboration. Next, we have Industry 4.0 challenges also simultaneously when we are introducing the like Industry 4.0 revolution. Whenever we talk Industry 4.0, there are certain challenges that comes in the process. There are data security. Why? Because there is a lot of risk for the data. That's the foremost challenge that is available in front of industries. And next one is train human resources, team support, leveraging data, high cost. Then we have IoT, that's Internet of Things, intelligent robotics, additive manufacturing, advanced composite materials. Next, we have modern manufacturing methods. So, what are the modern manufacturing methods that are being used in the industry? Means when the industries were started, maybe it was mostly a labor oriented manufacturing concerns. They were morely dependent on the labor, but in the due course, there are n number of technologies or machines that have been used, because in general any material is processed through either by removing or by forming or shaping or assembling in making some particular product. So there are major methodologies of production, like just in time, just in sequence, lean manufacturing, etc. Guiding principles of modern manufacturing methods. So we have three concepts, which will talk about the what are, that a principle that where modern manufacturing methods follow, or the modern manufacturing methods are carried with the help of these three concepts. They are waste reduction, product quality, and mass production. So here first we talk about waste reduction. So when we talk about waste reduction in manufacturing, that to reducing the waste to the maximum extent in the manufacturing process is one of the crucial activity that has to be carried out or looked after. Why? Because normally reduction of waste is related to recycling waste management. Earlier manufacturing methods allowed for waste and excessive consumption of supplies in water, or in order to meet their goals of mass production. So under waste reduction, we have lean manufacturing, JIT, that is just in time, Kanban, just in sequence. So these all methods, what we discussed earlier, these all methods are used to reduce the waste in the manufacturing concern. And apart from just in sequence, we have total productive maintenance, quick response manufacturing, cellular manufacturing, single minute exchange of die. Next, we talk about when we are going to implement or reduce the manufacturing wastage. There we will come across the problem of the product quality. So under this, we define this with the help of Six Sigma, which is DMAIC, that is define, measure, analyze, improve, and control. So this Six Sigma methodology is focused on improving the basic manufacturing process that are already in motion, which are in already in motion. Next, we talk is DMADV, that is define, measure, analyze, define, and verify. And this is an alternative methodology, is a more anticipatory approach. It is based on analysis of customer demand or manufacturers plans ahead and try to design ways to avoid defects in the first place or first place. Yeah. Next we have is CTQ and QFT, that is critical to quality and quality function deployment. These two concepts try to pinpoint the elements of product that are most important to customers and translate those for the needs into a manufacturing strategy that focuses on getting critical elements exactly right. And next we have is SIPOC, that is supplies, inputs, process outputs are customers. And this is about a diagrammatic tool that allows manufacturers to trace life cycle for the product from supplier to customer. And the last comes Taguchi loss function. If a manufacturer designs a production plan that will maximize the product and efficiency, and any change or variation from plan pose a problem. So the Taguchi loss function suggests that production quality decreases as variation increases. That is about product quality. Now, when we talk about mass production, when you're producing the goods in a larger quantity, in a bulk quantity or in a huge quantity, then our main motto is machine flexibility, routing flexibility, and we use CAD, that's computer aided design, and CAM, computer aided manufacturing, computer integrated manufacturing also. Different types of rapid prototyping. Here the different point that comes under the rapid prototyping and its applications. There is advantage and disadvantage of rapid prototyping. Then comes the concept of nano manufacturing. It's a product of nano manufacturing where a gauge wire approximately 1.3 millimeters is in diameter, made from carbon nanotubes that was spun into thread, and the same wire on a 150 ply spool. We try to do that. Similarly, if you just look at your ply spool made from carbon nanotubes, which are used. Next comes production support systems. So, in order to support the production system, we have automatic conveyor systems, automated guided vehicles, rail guided vehicles, and industrial robots. So here again under this we have a four functions where manufacturing support involves a cycle of information. Processing activities can be described as consisting of four functions. They are business functions, product design, manufacturing planning, and manufacturing control. Then comes non-traditional machining process, advantages and disadvantages. We'll move to the next topic, that is automation and robotics. Here we talk about it's in the evolution of robotics and automation. What is its meaning, reasons, advantages, disadvantages of automation, what are the types of automated manufacturing systems, robotic meaning, subjective, need for using robotics in industries, is it required, what is the law of robotics, anatomy of robots, types of drive systems, robotic sensors, specifications, robotic applications in automotive manufacturing, its application in space, medical and defense, advantages and disadvantages of robots. So like this, we have different points that has to be raised. So just look at here, what is the meaning and reasons for automation? Let's look into that. Automation is a technology which a process or procedure is accomplished without human assistance, and it is implemented using a program of instructions combined with a control system that executes instructions. And the reasons for it is to increase labor productivity, to reduce labor cost. Why? Because when you're going for automation, obviously there will be more use of machines rather than the labor payments. And to mitigate the effects of labor shortages, to solve the problem of labor shortage, as well to reduce or eliminate routine, manual, and clerical tasks, to improve worker safety, and to improve product quality, to reduce manufacturing lead time, to accomplish process that cannot be done manually, to avoid the high cost of not automating. And when you talk about the disadvantages of automation, we have less variability, because by having a machine that can perform a certain task limits the flexibility and variety of tasks that an employee can do. So it's of no use when an employee can do. What is the use of robots? Next, more pollution, because when you use more machines, more chemicals, more gas, so there's a lot of chance of pollution. And large initial investment, because it requires a huge investments to start any business. Increase in unemployment. By increasing the amount of automation, there are less employees required, causing high unemployment rates. Next is types of automated machines, automated manufacturing systems. Under that, first one is fixed automation, and the next one is programmable automation and flexible automation. When we talk about fixed automation, this is a system which is a sequence of process. It's an assembled one, which cannot be removed. It's a configured one, like simple involving perhaps a plain linear rotational motion. A combination of two. For example, the feeding of rotating spindle is the integration and coordination of many such operations. And features of fixed operation automation are high initial estimation for custom engineered equipment, and also high production sets, or rather than that, they can have relatively inflexible in accommodating product variety. Next, programmable automation. It is as per the program, it will be changed and it can be accommodate different product configurations. And its features are high investment in general purpose equipment, lower production rates than fixed automation. And when we talk about flexible automation, it can be moved or kept or done virtually or online also. And here, high investment in custom engineered systems. Continuation production of variable mixtures of products and medium production rate. Flexibility to deal with product design variations. And next comes robotics, its meaning and objectives. And robotics is a multidisciplinary field which involves mechanical, electronics, and several other engineering disciplines. But robotics is defined as the science of designing and building robots which are suitable for real life. So, very not that much feasible. So, it is defined as which are suitable for real in life application, and it has the objectives like to increase productivity, reduce production life, and minimize labor improvement or labor requirement, enhanced quality of the products, minimize loss of man hours on account of accidents, make reliable and high speed production. Need for using robotics in industries and laws of robotics. And even we have some structure how to like we have an anatomy of robots, what should be kept, what are the parts that should be used. And there are several classes of robots like robotic aircraft, robotic ships, mobile robots, and others. So anatomy and subsystem of robots, we have actuators, means they are basically prime movers providing both force and motion, like pneumatic cylinders, hydraulics, permanent motors, stepper motors, linear motors are some example which are conventional actuators. Most I would and next we have is transmission system, power supply, sensors, electronics, and software. And we have types of drive systems. In this, we have electronic, pneumatic, and hydraulic. Because these three are main types of actuators that are currently used in robots, like electronic, pneumatic, and hydraulic. When we talk about electric. All robots use electricity as the primary source of energy, and electricity turns the pumps that provide hydraulic and pneumatic pressure. It also powers the robot controller and all the electronic components and peripheral devices. And when you talk about pneumatic, these are generally found in relatively low cost manipulators with low load carrying capacity, and pneumatic drivers have been used for many years for powering simple stop to stop motions. And when you talk about hydraulic drive systems, under hydraulic drive systems, they are either linear position actuators or rotatory vane configuration. And again, we have robotic sensors. Under this, we have three categories, that is vision sensors, tactile and proximity sensors, and voice sensors. So in robots, whenever we use for them, there is a type of workstation control which uses interlocks is not adequate. So what they are doing, they use the senses, human senses like hearing, eye coordination, touch. That feel has been injected into the robots with the help of sensors. So under that, the first one is vision sensor, which will provide a vision to the robots like video camera. They can, like eyes, they can use it and grasp what is happening. They can retrieve parts which are randomly oriented on a conveyor. Next comes tactile and proximity sensor, and this provides the robots with the capacity or capability to respond to contact forces between itself and other robotic objects within the work volume. And tactile sensors can be divided into two types, touch sensors and stress sensors. Next, we have voice or sound sensors. So, the another area of robotics research is voice sensing or voice programming. Here, voice programming can be defined as the oral communication of commands to the robot or other machine. Next, they have given specification like speed, load bearing capacity, repeatability, and precision. And robotic applications in automotive manufacturing. So, where all these are used, like collaborative robots, robotic painting, robotic welding, robotic assembly, material removal, part transfer and machine trending, spray painting, and apart from that, robotic applications in space and medical and defense. Robots are used mostly in the space. Higher percentage of robots are used in the space. Then comes the medical, and then comes the defense. Next is HRD practices and performance measurement. Under this, we discuss about, we have four topics, that is human resource dimensions in world class manufacturing, key performance indicators, performance measurement, and environmental impact on WCM and green audit. So these are mandatory to carry out the any paper, or this information is enough. Means here we are trying to find out that human resource dimensions in world class management means how we are using the human resource HRD practices in the WCM, and what are the key performance indicators we are going to look after, how we are measuring their performance, and do we have any environmental impact on WCM and green audit. So under that, first we discuss is HRD dimensions in WCM. So HRD dimensions in WCM, if you look at there, we have a teamwork, employee engagement, integration of human resources and manufacturing strategy, employee benefits and rewards. So now let's look at what is human capital, how it can be perceived based on different dimensions, and examined according to their influence on firm performance, while human capital dimensions are crucial factors while influencing the firm performance. So, under this, we have certain challenges that are going to be faced that are serious HR challenges. Under that, first one is recruitment difficulty. Why? Because the large number of job positions to be filled poses a challenge for the HR. Why? Because the task of filling many job positions, even furthermore, it's complex for the need of specific skill set by the worker. Here, manufacturing industry looks for the skilled workers, and there is a shortage of people with right skill sets and abilities. Next is employee retention. An increase in turnover rate in manufacturing industry is a common phenomenon as people often leave to explore new and exciting opportunities. And the other reasons for increase in turnover rate may be due to no growth or development of the employee on both professional and personal front, or low pay package, or lack of benefits, or poor work environment. And global competition, as this increases the task of making the company attractive to top talent and innovators. This age of cutthroat competition can be reduced. It's a challenge for us. And next comes the training and development. Here it's a sphere where HR will try to operate its optimum, and it's equally essential to provide adequate training to employees. And in order to keep them updated with the latest developments in the industry and prepare them better for the upcoming challenges. And next one is decline in workforce. Next comes the teamwork. Here, teamwork means it can be linked, or it's a sense of unity. We feel we are united, and enthusiasm for common interest and responsibilities will be developed among a group of persons closely associated in a task, cause, enterprise, etc. And teamwork synergizes because it supports more empowered way of working, removing constraints, or promotes flatter and leaner structures with less hierarchy, encourages multidisciplinary work where teams cut across organizational divides, and fosters flexibility and responsiveness, especially the ability to respond to change, pleases customers who like working with good teams, and also promotes the sense of achievement, equity, and essential for motivated workplace. When managed properly, teamwork is a better way to work. And the elements of effective teamwork are commitment and trust, openness, open lines of communication, diversity of capabilities, adaptable to changing conditions, confidence and creative freedom, culture of ideas and innovation, reward team for team taking risk, clear organizational purpose, concrete team goals, delegate the task based on its strength. And next we have teamwork skills, like skills required are listening, questioning, persuading, respecting, helping, sharing, participating, and communication. This all comes on teamwork skills. This all should be there. And when you come talk about the teamwork strategies, we have few strategies that improve teamwork, like embrace the diversity of the workforce, build a culture of trust, promote effective communications, and few other measures to improve the teamwork that are led by example or by build up trust and respect, encourage socializing, cultivate open communication, clearly outline responsibilities, roles, organize team processes, set defined goals, recognize good work, mediate conflict quickly and efficiently, use a task management software, maintain the balance of work, and meet regularly and mix it up, create space, start team traditions. So this all comes under the strategies that improve teamwork. Next is employee engagement, and this I think from this Remaining we discuss in the next class about the employee engagement and the remaining part. Okay. Yes. Anything?
No.
Can can we continue the next class, remaining one?
Yes, ma'am.
Yes.
Yes, ma'am.
Okay. 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 Thank you.